These are the interfaces where GTP version 2C is utilized, between the mobility management entity and the serving gateway on S11, between serving gateway and packet data network gateway on S5, S8, between two MMEs on S10. GTP-C is also the signaling protocol used between Evolved Packet Core and UMTS, between MME and serving GPRS support node on S3, and between serving gateway and SGSN on S4, between two SGSNs on S16. This interface exclusively uses GTPv2C and for 2G, 3G access only when on an EPC network, used to transfer individually UE context. The GTP protocol is specified by 3GPP. When non-3GPP access was added to the 3GPP core network, a tunneling protocol specified by IETF was chosen instead, the Mobile IP Protocol. To be able to separate tunnels, GRE keys, generic routing encapsulation, are used instead of TEIDs. The non-3GPP access technologies are divided into trusted or non-trusted. This division is based on the business relationship between the network owners, not on the used technology. Examples of technology can be wireless LAN and WiMAX. But there is also a technical division between non-3GPP access technologies based on if the UE is the endpoint of the tunnel or not. If the UE is the endpoint of the MIP tunnel, it is called host-based. A network-based solution means that the MIP tunnel does not have its endpoint in the UE, but in a node in the network. In the case of a trusted access network, the function that ends the tunnel is the only one required by the network. This function is handled by the MAG, Mobile Access Gateway. When the communication takes place over an untrusted access network, the operator will place a trusted node in the middle, called the Evolved Packet Data Gateway. The EPDG is responsible for tunnel authentication and authorization and lawful intercept. It will also enforce OOS based on information from AAA and OOS market packets on the transport level. It will encapsulate IPsec packets and proxy MIP. In the case of a S2B interface, it will work as a MAG and allocates GRE keys for the MIP tunnel. In the case of the S2C interface, it will allocate the remote IP address to the UE for COA usage. Between the UE and the EPDG, IPsec shall be used. The MIP can also be used within the 3GPP network on the S5, S8 interface. As long as handover occurs within the LTE access network, the handover can occur between eNode Bs belonging to the same serving gateway, or between eNode B belonging to different serving gateway. In the first case, the serving gateway will be the anchor point. In the second, the PDN gateway will be the anchor point. When the handover takes place between two different 3GPP-based access technologies, the serving gateway will be the anchor point, called 3GPP anchor. If the UE continues into a non-3GPP access technology, the serving gateway will be released, and the PDN gateway will be used as non-3GPP anchor. The protocol stack for a GTP version 2 based interface includes GTPC on top of UDP and IP. Then, over some type of Layer 1, Layer 2 protocols. The source and destination IP addresses included in the IP header and the UDP ports in the UDP header depends on the role the message plays. A message can be an initial message, a triggered message, and a triggered reply message. The UDP destination port shown here is the registered port for initial messages. If the initial message is a request message, it will be followed by a triggered response message. Triggered responses are the only messages that can carry a piggybacked message. Piggybacking is an optional feature. It is indicated with the P bit in the GTP version 2C header, with P set to 1. There are only 2 triggered response messages in GTP version 2C, defined for piggybacking, create session response and create bearer response. All other messages has the P bit set to 0. The T bit indicates if tunnel endpoint ID is included or not in the GTP version 2C header. There are 3 types of GTP PDUs. 2 used for signaling, GTPC and GTPU, and 1 carrying user plane traffic named GPDU. The PDUs are sent across tunnels. A GTP tunnel is identified in each node with a tunnel endpoint identity, an IP address, and a UDP port. The TEID is locally assigned by the receiving side. The assigned TEID values are exchanged between the tunnel endpoints using GTPC or S1MME messages. How the tunnel shall be configured and utilized differs between the control plane and the user plane, and also between different interfaces. The rules for the control plane are as follows. On the S3, S4, S10, S11, and S16 interfaces, there should only be one pair of TEID-C per UE. The same tunnel shall be shared for control messages related to the same UE operation. The TEIDC shall be released after all its associated EPS bearers are deleted on S4 and S11 interfaces. On S3, S10, and S16, the TEIDC shall be released after all its UE context is removed or the UE is detached. On the S5, S8 interfaces, there shall be a unique TEIDC pair per PDN connection. The same tunnel shall be shared for control messages related to all barriers associated to the PDN connection. The TEIDC shall be released after all its associated EPS bearers are deleted. A control plane GTP message consists of a GTPC header followed by 0 or more information elements. It is sent across a GTP control plane tunnel and used for control plane path messages, control plane tunnel management, and mobility management. User plane messages are used to carry signaling messages for user plane path management and error indication, or to carry user data packets. The GTPU message consists of a GTPU header followed by 0 or more information elements or a TPDU. The network consists of an access part, EU-TRAN, and a core part, Evolved Packet Core, EPC. These parts form Evolved Packet System, EPS. From an end-user point of view, it is the experience quality of service, end-to-end, that is the only relevant quality of service. This end-to-end service can be subdivided into an EPS bearer and an external bearer. The EPS bearer is the bearer that is, from a quality of service perspective, controlled by the mobile operator and defined by specifications developed by 3GPP. The quality of service solution from the external bearer will in many cases be beyond the control of the mobile operator and built on techniques developed by IETF, like diff-serv and MPLS. An EPS bearer is established when the UE connects to a PDN gateway and remains established throughout the lifetime of the PDN connection to provide the UE with always-on IP connectivity to that PDN gateway. That bearer is referred to as the default bearer. Any additional EPS bearer that is established to the same PDN is referred to as a dedicated bearer. The EPS bearer can then be divided into the ERAB, EU-TRAN radio access bearer, and the S5, S8 bearer. The radio bearer and the S1 bearer form the ERAB. When establishing the EPS bearer, the EPS quality of service profile will be communicated over the different signaling interfaces. The EPS quality of service profile is defined by 4 parameters. QCI, Quality of Service Class Identifier. The QCI is a scalar parameter pointing to standardized characteristics defined by the operator policy decision. The decision depends on expected traffic load versus dimension capacity parameters, traffic class, traffic handling priority, signaling indication, and source statistics descriptor. QCI is used as a reference to access node-specific parameters that control bearer-level packet forwarding treatment, scheduling weights, admission thresholds, queue management thresholds, link layer protocol configuration, etc. QCI has been pre-configured by the operator at specific nodes, for example, eNode B. ARP, Allocation and Retention Priority, specifies the relative importance between ERABs. The primary purpose of ARP is to decide whether a bearer establishment modification request can be accepted or needs to be rejected in case of resource limitations. In addition, the ARP can be used by the eNode B to decide which bearers to drop during exceptional resource limitations, for example at handover. GBR, Guaranteed Bitrate, the bitrate that can be expected to be provided by a GBR bearer, defined per EPS bearer and only valid for GBR bearers. AMBR, Aggregate Maximum Bitrate, limits the bitrate for all EPS bearers belonging to the same PDN, only valid for non-GBR bearers. The UE uses the uplink packet filter, uplink TFT, to determine the mapping of uplink packets to the radio bearer. Every EPS bearer is associated with an uplink TFT in the UE and a downlink TFT in the PDN gateway. The GTP version 2C messages are organized into groups: Path Management, Tunnel Management, and Mobility Management. The underlined messages are the ones that further on will be described in deeper detail. The rest of the messages are organized into the following groups: CS, fallback, and SRVCC related messages, non-3GPP access related messages, reliable delivery of signaling messages, error handling, path failure, restoration and recovery, fallback to GTP v1 mechanism, fallback to GTP v0, trace management messages. Create session request is used as a part of EU-TRAN initial attach and UE requested PDN connectivity, and is sent by the MME to the serving gateway and onwards to the PDN gateway. The message will also be sent on the S4 interface during PDP context activation from SGSN to serving gateway to PDN gateway. Create session request will also be sent during tracking area update and handover when the serving gateway is changed from the MME to the serving gateway on the S11 interface. It can also be sent on the S4 interface as a part of the routing area update and handover procedure with change of serving gateway. This traffic case shows the usage of the create session request and create session response. This traffic case shows the usage of the create session together with create barrier. There are two situations when they can be used together: when the establishment of the default bearers in the initial attach procedure is combined with establishment of dedicated bearers, and during UE requested PDN connectivity. The information about the dedicated bearers to be established is carried in the create bearer request, piggybacked by create session response sent from the PDN gateway. The create bearer response will then piggyback the modify bearer request. The piggybacking of the modify bearer request will only occur if the create bearer request was earlier piggybacked. Create bearer messages can also be sent as standalone messages as a part of the dedicated bearer activation procedure, and in case of S4 interface in the secondary PDP context activation procedure. These are the information elements included in the create session request. They are sent from the MME to the serving gateway and from the serving gateway to the PDN gateway. The message carries information about the bearer context that is to be created. Which tunnel endpoint identity is going to be included depends on which interface the message is sent upon, marked in brackets. If you would like to learn more about the information elements, please click on them and they will take you to a descriptive table. These are the information elements included in the create session response sent from the PDN gateway to the serving gateway and from the serving gateway to the MME. The message carries information about the bearer context created. Which tunnel endpoint identity is going to be included depends on which interface the message is sent upon, marked in brackets. The create session response can also piggyback a create bearer request if dedicated bearers are about to be set up in the case of initial attach or UE requested PDN connectivity. If create bearer request is piggybacked, it will be marked in the GTP header with the P bit set to 1. In this presentation, create bearer request is only shown as piggybacked by the create session response. But if create bearer request and response are used as standalone messages, they will contain the same information as shown here. These are the information elements included in the Create Bearer response. The message carries information about the bearer contexts. The tunnel endpoint identity to be included depends on which interface the message is sent upon, marked in brackets. The Create Bearer response can also piggyback a modified bearer request if dedicated bearers are about to be set up. If modified bearer request is piggybacked, it will be marked in the GTP header with the P bit set to 1. The modified bearer request will only be piggybacked by the Create Bearer response if the Create Bearer request was piggybacked by the Create Session response previously. Modify Bearer request is sent by the MME to the serving gateway and onwards to the PDN gateway during these procedures. The message will also be sent on the S4 interface during PDP context activation and inter-RAT handover from SGSN to serving gateway to PDN gateway. These are the information elements included in the Modify Bearer request. These are the information elements included in the Modify Bearer response. The message carries information about the bearer context modified. The tunnel endpoint identity to be included depends on which interface the message is sent upon, marked in brackets. This traffic case, S1 based handover, is defined in 3GPP Technical Specifications 23.401. The handover in this example leads to that not only the cell is changed, but also the serving gateway and the MME. The handover is also S1 based, meaning that the two base stations do not have the optional X2 interface between them. In this example, indirect forwarding of user data packets will be covered. The user data packets will not be sent direct between the two eNode Bs, but indirect via the serving gateways. Source nodes are marked in green and target in blue. The first message, shown here, is the source eNode B, sending a handover required to the source MME. The source MME will then contact a target MME. Which one to choose is not covered here, but in 23.401. The source MME sends a forward relocation request to the chosen target MME. This message contains information about the old configuration. The target MME selects a serving gateway, which shall allocate resources for the bearers to be set up. This information is sent to the target MME in the Create Session response. Since we are about to follow indirect forwarding of user data packets, resources for these bearers must also be allocated using the messages create indirect data forwarding tunnel request response between target MME and target serving gateway, as well as between source MME and source serving gateway. The source eNode B will inform the target eNode B about the PDCP status for the services that are required to preserve the status in an eNode B status transfer S1 AP message. This information will be passed between the two MMEs in the forward access context notification. Since this example covered change of serving gateway, the S5-S8 bearer needs to be relocated towards the target serving gateway. This is done with the modify bearer messages sent to the PDN gateway. These are the information elements included in the forward relocation request. The request is sent between two MMEs as the initial GTP-C message when a new MME has to be assigned. These are the information elements included in the forward relocation response, which is the response from the newly allocated MME to the old MME. These are the information elements included in the Create Indirect Data Forwarding Tunnel request. Since no X2 interface between eNode Bs exists in this handover example, the user packets belonging to error-sensitive services have to be forwarded in an indirect tunnel, passing over the core network. The target MME is responsible for establishing the tunnel between the target serving gateway and the target eNode B. The source MME is responsible for establishing the tunnel between the source serving gateway and the source eNode B. These are the information elements included in the Create Indirect Data Forwarding Tunnel response. These are the information elements included in the Forward Access Context Notification and Forward Access Context Acknowledge. For error-sensitive services, it is important that the target eNode B will become aware of the PDCP sequence number. This information will be carried in the core network in these messages. These are the information elements included in the Forward Relocation Complete Notification and Forward Relocation Complete Acknowledge. Downlink data notification is used to indicate to the MME or to the SGSN that there is incoming data to an idle UE. This is shown in this picture. The IP packet to the idle UE will arrive to the PDN gateway. During the initial attach, a default bearer is established between the serving gateway and the PDN gateway. Therefore, the PDN gateway doesn't need to be aware of if the UE is idle or connected. It just passes the IP packet on to the serving gateway. The serving gateway is aware of that the UE is idle, since no bearer exists on the S1 interface. Idle UEs need to be paged in the register tracking routing area, which is handled by the MME or SGSN. The serving gateway will therefore send a downlink data notification message to the MME or the SGSN. These are the information elements included in the downlink data notification and downlink data notification acknowledge.